other things we have learned?
The features and properties of liquid pressure.
Okay. Can you tell me that points? Can you read it? Because there are so many points, so I just want to know which you did not discuss. That's why.
Hydrostatic pressure and hydraulic pressure.
Only that much. Okay. Did we then?
Liquid pressure does not depend on area.
Okay. Next point.
Liquid pressure at any point inside the liquid depends upon the density and the height of the liquid column above that point.
Okay. Very good. Next.
Liquids exert sideways pressure.
Sideways pressure. So that was the last point we discussed. Correct? Is there any other point? Is there any point we missed out? Nasreen, you were present in the last class. I hope so. Is it so,
Yes,
Nasreen? Yeah. This much only we discussed now. Okay.
Yes, ma'am.
Yes. Okay. Fine. So we have learned. We are in the halfway of liquid pressure. So without wasting the time, we will go to the next one. Okay.
Ma'am, my
Yes.
seminar is left.
Yes.
My seminar is left to do.
Yes, I know it, but I think since we are running short of time, let me complete, then we can have it. Okay, Gopika. When we do the revision, I will make you to do the Parvati. We will make you to do the seminar. Okay, let us complete the portion now. Okay.
Okay, ma'am.
Is everyone is come? Because so many are absent. Okay, we'll start now. Oh, I forgot to record it. Okay, so that is about air pressure. Ma'am, I cannot see that. To change this. Where it is? Yes. I cannot see that. 1 minute. Where is gone? Okay, children. This board is little more slow. That's why we getting delayed. Okay. I think the last class we have already completed all these points. So this is about the more dense the liquid, higher the pressure at any particular depth. That is over. And we also have learned the pressure. So far we have learned the impact of the liquid pressure as well as air pressure. And one more point, we have to write it that pressure doesn't depend on the shape of a container. So liquid pressure doesn't depend upon the shape of the container. If you can see that in this picture, this is the 4 different containers. Okay, 4 different containers. So 4 different containers connected together, and you will be seeing here there is a 4 points at the same depth. So there is already, we have learned that the pressure is exerting sideways. It's the same point, little more elaborately. If you look at this 4 containers which is connected, the shape of the container is different, but still the pressure experienced by A, B, C and D both will be same. Okay, so this is the next important point. After you have already written the pressure exerting on sideways, under that you can write this point. Whatever the shape or width, the pressure at any particular depth is the same. So that is the next important point regarding the liquid pressure or fluid pressure. Whatever the shape or width, the pressure at any particular depth is same. So here A, B, C, D. These are the 4 points at a particular depth, at the same depth. All are at the same depth, but the container size and shape is different, but still it experiences the different shape. Did you write, all of you?
Yes, ma'am.
Okay. Shall we go to the next one?
Yes.
What's this? What all this is coming out? Okay. The next point, what we are going to learn, atmospheric pressure. We already learned about atmosphere. How far atmospheric pressure extends in our earth. So before I go to atmospheric pressure, I need to show you some activity which is given in your textbook. Okay, that slide is missing. Okay, we got atmospheric pressure. Next class, I will show you that extra activity. There are some 3 activities is mentioned in your textbook. We will discuss in the next class. We will now complete with this atmospheric pressure now. Activity, we can keep it for the next class. Yes. So the atmosphere is this is already you have learned in geography class, and also it's not necessary to write, but you only just understand. The atmosphere is the layer of air enveloping the earth. It extends up to how much distance from the earth's surface? 1,000 kilometers. It is extends up to 1,000 kilometers above the surface. And what is the mass of the air in that? 4.5 into 10 to the power of 18. 4.5 into 10 to the power of 18. That means 4.5 into 10 into 10 into like this 18 times. Okay. So that much is the mass of the air which is surrounding the earth. The pressure inside our body is almost the same as the external pressure and balance is. Already I discussed with you. At high altitudes where the pressure is lower, breathing is difficult. Nose bleeding may occur as a result from the pressure difference between the body and the external pressure. Okay, so this is what I discussed in the case of a mountaineer who carry. So in a normal life, it's very important that our pressure, blood pressure and the air pressure which is exerting on us are equal. But when you go to higher altitudes, air pressure decreases. Now, what is the value of the pressure which is acting on our human body? Okay, that's what we are going to see. This is around 1 lakh Pascal. Can you see it, children? So this is the value or magnitude of air pressure acting on us. 1 lakh Pascal. So 1 lakh Pascal is exerting on our body. The similar way, our blood also exerting the same amount from inside. So as a normal person, you experience this much, but we don't feel it. Air is pushing us, but we don't feel it. The reason is that our mass is more, our body, due to gravitational force, we don't feel that much. Clear? So this is the amount of air pressure acting on us at a normal temperature, and the same amount of blood pressure also acting on from inside our body. So any person has some problem due to sickness, this blood pressure vary. So person who has more blood pressure, we call it high BP. high BP person, maybe your parents, maybe your some of your grandmother, grandfathers, all may suffer now pressure problems because of imbalance in the body. As we become old, naturally our body may not work like a normal human being. So naturally that person can go to high BP or low BP. High BP means the person who has got a high blood pressure than this. Low BP means the person who has a less pressure than this. So these people, we don't feel okay with it. Okay. So did you get that point? So 1 lakh Pascal is the total amount of atmospheric pressure is acting on us. Now there is some application in our daily life. Now everyone is very known about the vaccination is taking place in our state, correct? So there is a principle also behind that injection. The nurses are filling the medicine in that on the basis of liquid pressure. So if you look at this picture, how does the syringe is filling with the medicine? The reason is when the piston, so you can see the back of the syringe, there is a piston, we can move forward and backward. So whenever the nurses wants to fill the medicine, she pushes the piston backward. After filling it, she will inject the medicine to us, pushing backward that piston. Okay. First, she will take it upward and then she will push backward in order to inject the machine. So there is also a principle behind it. So that is the principle. When the piston is pulled up, atmospheric pressure inside the cylinder will decrease. Atmospheric pressure inside the cylinder means before filling the medicine, what does the syringe has? Only air inside it before filling it. So inside the syringe, there is atmospheric pressure. So one piston is pulled up, what happened? This atmospheric pressure reduces or air escapes from it when you push the piston backward. Then what will happen? The outside the syringe, atmospheric pressure become more than the inside pressure. As a result, what will happen? The medicine will get inside the syringe. So this is a daily life example where liquid pressure impact on us. So when the piston is pulled up, the atmospheric pressure inside the cylinder will decrease. Then outside pressure is more. So outside pressure will push the medicine inside the syringe. This is also an application. Another application, very simple, everyone likes to drink, correct? You go to a cool drink shop and you will use the straw to drink juice and shake and all. In that also same thing. As you, the same thing, what is the same effect on that? Hello? When a person sucks through the straw, the pressure in the straw become low. So what you do? You are removing the air from the straw when you blow air inside your mouth. As a result, what will happen? The atmospheric pressure outside is higher. Then it will force the water or the juice into the straw and you can able to drink it. So this is also a single application where what we do due to liquid pressure. Okay, so when you suck the straw, you are removing the air pressure inside the straw, then straw become empty, then outside the straw pressure is more, that will push the juice or water into the straw and you will be able to drink it. Okay, and last application what I am going to discuss is this vacuum cleaner. One vacuum cleaner also is there. Yeah, vacuum cleaner. The working of the vacuum cleaner also same. Okay, you can see the dust. When you switch on the vacuum cleaner, what does it have? The vacuum cleaner will suck when the vacuum cleaner is switched on, it sucks out the air inside the cleaner. So before dust sucking, vacuum pump has got air. So when you switch on it, what will happen? The air inside the vacuum pump will be removed and from outside atmospheric pressure is becoming more and it will push us the dust inside the vacuum pump from the furniture and carpet, all this. So this is also an application for liquid pressure. or fluid pressure. Okay, this is actually example for air pressure, and straw, drinking straw, injection and all, it is a mixing with the liquid and as well as air. So that is why all the points related to liquid pressure is applicable also for gas pressure. So this is, we commonly call it as a fluid pressure. Okay. Okay, children, is it clear to you? So what is the impact of the liquid pressure, air pressure? So you have to think about the situation. In which situation are you living? According to that, we are having. So for example, if you talk about the liquid, I mean, it's water, then you have to give the answer in terms of water. Suppose I am asking question related to air, you have to use the same terminology. So both gas pressure and liquid pressure, factors which is affecting is same, density and height of the column. If it is liquid, we call height of liquid column. If it is air, we call height of air column. That is the only difference. Okay, so air is less denser than any other gases. Similarly, water and kerosene, water and oil. So water is less denser than oil. Okay, so all that you can, I can give you more activity. It is then the textbook that we will discuss in the next class. So Parvati and Shreya, so next Friday we will have your seminar, and then I continue, because we are almost come to the end of this chapter. Only few more things I need to clarify with you, then we will complete this chapter. Okay, so Parvati and Shreya, yes, Menon, be ready. Okay,
Ma'am.
Okay, yes,
Ma'am,
Mm.
ma'am, tomorrow is the last date for the submission of that PPT, right?
Yes, but still I did not get many. So I have got only few students. So rest of the students, please complete by this week. Okay. Yeah, because we need to concentrate on our PT1 exams next week onwards. Okay. Okay. Thank you, children.
Thank you, ma'am.
Yeah.
Thank you,
Total, how
ma'am.
many students you are? Yeah. Okay. Some 9A students also joined, I think. Fine.